Good evening and welcome. My name is Rodney Phillips. I'm the Dean of Medicine at the University of New South Wales. In welcoming you here today, we acknowledge the Gadigal people of the Eora Nation, whose traditional land we are gathered upon, and we acknowledge their elders past and present, the custodians of the land. The Dean's lectures at the University of New South Wales have, to my great pleasure, expanded to be an important time in the calendar of this university. And on behalf of the University of New South Wales and the Faculty of Medicine, I'd like to invite you to stay with us this evening for our talk. Those of you who study historical events will be aware that from time to time, completely without any expectation, a catastrophe arises. In the case of the human condition, there's no doubt that infectious agents that form a plague upon us are and will remain one of the true threats to existence on Earth. In fact, in think tanks, where they think, allegedly, where risk is assessed from a national, continental, or even a global sense, infectious agents tend to appear quite close to the top. And of those infectious agents that are considered to be potentially problematic, viruses with a genomic structure made of ribonucleic acid are often considered to be the most awful of all. The late Sir Peter Medawar, who was a Nobel laureate in immunology, wrote a number of short but very pithy texts in the field of biology. And in the case of his view of viruses, he said it was a small but awful piece of trouble wrapped up in a protein. Many viruses that plague humans are in fact derived from animal populations, and indeed it's the story of many infectious agents that they are found in animal locations within animal populations, and periodically they leap across into the human population. The technical term for this is a zoonosis, and many of the infectious agents that give us so much trouble are zoonotic. That jumping across event might have occurred in the very distant past, but in the case of the human immunodeficiency virus, this jump seems to have occurred in the 20th century. And at some point around the mid-points of the 20th century, a piece of trouble wrapped up in a protein leapt into African populations. Now, the virus that did that was a retrovirus, so called because although composed of a ribonucleic acid genome, an RNA genome, the virus has the extraordinarily sinister capacity to copy itself into DNA and insert the DNA into the nucleus of the host cell. So in the case of humans, if we're infected by an infective retroviral infection, the ribonucleic acid of the retrovirus is transcribed into DNA, and the DNA is then beautifully tied into the nucleic acid of the host cells, that is our cells. If you were trying to design a virus that was particularly difficult and sinister, this type of infection would have to be one of them, particularly now that the virus is in a new host that has no previous major adaptation. That virus is potentially very dangerous indeed, but also eradication of a virus that is already tied into your genome also looks, from a scientific point of view at least, exceedingly troublesome and difficult to get rid of. So 35 years ago or so, with the emergence of an epidemic of immunodeficiency in human populations, such a retrovirus was identified, and from that point on, a great deal of effort has gone into understanding what these viruses are, what the immune response to them might be, what we might do to eradicate them or at least treat them. And as we've heard over the years from a number of the doyens of this field, amongst whom David Cooper is here today, this is one area of medical science where there has been a genuine triumph. And the triumph has been to, first of all, identify the virus responsible for the immunodeficiency state that it provoked, but then to develop tests that allowed the screening of blood particularly, and of course of humans, infected or otherwise. But the great revolution in the field has been, and I speak as an immunologist here, a pharmacological solution, which is to provide combination drugs, which are extraordinarily effective in controlling the infection but not eradicating it. Tonight, Clifford Lane is here, having travelled from the United States and from the National Institutes of Health, and he is going to deliver his oration on this topic, the HIV epidemic, and the 35 years in which we've been dealing with it, and what he sees as the future. If I could just give a few biographical points on Cliff Lane. He is currently Clinical Director of the National Institute of Allergy and Infectious Diseases at the NIH. He was born in Detroit, Michigan, a place where I gather they used to make cars with financial success. He received his MD and his residency training in internal medicine at the University of Michigan. He started his career at NIAD in 1979 as a fellow in infectious diseases in clinical laboratory immunology. When the epidemic that I alluded to came upon us, he turned his attention to studying immunopathogenic mechanisms of HIV disease. Immunopathogenic means when the immune system may not be doing all that it should from the benefit of the host, but may actually be inspiring some damage. Complex processes in HIV. He went on to look at immune-based therapies, and eventually he collaborated with people all over the world, including those senior members of the Kirby who are here with us tonight, David Cooper, Sean Emery, and others. He obviously has enormous taste, not only in the field of endeavour that he's worked on, but also extraordinary taste in his collaborators in Australia. His current work is focused on HIV infection and some of the pathogenesis that lies behind it. But in response to the Ebola outbreak, another very serious bit of trouble wrapped up in a protein, Cliff has spent quite a bit of time in recent years in West Africa, in Liberia, and elsewhere, looking at that epidemic and finding, as you might expect, that good old quarantine works extremely well as long as you've got the right equipment. And he's also been instrumental in advising West African governments as to how things might proceed. As he and I know, when you enter the international stage of giving advice, there's always some potential for trouble, I guess I would say. The evidence that Cliff has got through this rather well is that he, not only is he a member of the US National Academy of Medicine, but he's also been awarded the Chevalier d'Ordre National du Mali, suggesting to me that he does indeed have the diplomatic skills needed. And finally, and probably the thing that he embraces most of all, is that within the United States Department of Health and Human Services, he's been given an award for distinguished service. And this was, of course, under previous presidencies. So, Cliff, it is my great honour, my great privilege on behalf of this great university to invite you to give the Dean's oration. Thank you very much.
Professor Phillips, thank you for that very, very kind introduction. I won't make Professor Cooper or Professor Emery refer to me as Sir Cliff, despite the Chevalier du Mali. So that was probably a secret I had hid from them, but I appreciate that being out in the open now. What I would like to do this evening is just share some thoughts with you over the past 35 years of working in HIV/AIDS, talk a little bit about what I see as some of the major advances, as well as what I think are some of the challenges that we are still facing. In the US, this disease first came onto the scene in 1981, hence 2016 being 35 years later. It came out in a series of publications from the US Centers for Disease Control, shown here. I can remember at the time, as Professor Phillips mentioned, I had gone to the NIH in Bethesda, Maryland in 1979, and at that time, the CDC would send these mailings out, and you could get it for free. It would come, in your mailbox, and I had a little chute on the door, and they would come in through the door. I remember getting the first one and reading about pneumocystis pneumonia, which I had heard of, maybe seen a case or two, but thought nothing of it. But then when the second one came in, I actually saved it, and I still have it at home, because it really was clear that something very extraordinary was going on with very unusual diseases occurring, and occurring in a very limited group of individuals, initially homosexual men, from there intravenous drug users, patients with hemophilia, transfusion-related cases. This just shows the death rates from a variety of different conditions in the US from 1982 to 1994. This was happening while we at the NIH, while the groups here in Australia and in Europe were beginning to try to understand this illness. And as you can see, from that time of those first reports in 1981, HIV/AIDS went from a minor problem, a minor cause of death, to the leading cause of death for individuals aged 25 to 44. What was particularly poignant about this for me, and I think for many of us who were working in this area at this time, is that these were young men, basically the same age that we were, coming in with a variety of unbelievably horrific conditions. And most of these were diseases that we maybe had seen once or twice in our training to that point, but now we're seeing basically on a daily basis. Here you see a patient with Kaposi sarcoma and the swelling due to blockade of the lymphatic system, the bruised appearance due to the invasion and the disruption of the capillary systems. Here's a very bad example of oral thrush or candidiasis, again related to the defect in immunity. This is the classic appearance of a chest x-ray of someone with pneumocystis carinii pneumonia. And what was interesting was in these patients, the amount of disease in each one of these black dots is actually a cyst of pneumocystis. The amount of disease, the amount of infection that these patients were experiencing was extraordinary. That the burden, in this case, of what is now known to be a fungus, of the bacteria for tuberculosis or atypical mycobacteria, whatever infection the patients with AIDS were getting, they were getting it in a way that was a bit unusual and a bit more severe than what we were accustomed to. This shows one of the other manifestations that, in addition to causing the decrease in immunity and the secondary infections and cancers as a result of that, HIV also directly affected a variety of organs, particularly the nervous system. And here you see the CT scan of someone. This inner part, the black part, is the ventricle, the fluid-filled space, and the middle part of the brain. This is enlarged, and it's enlarged because the cortex of the brain, the actual material of the brain, is shrinking due to infection with HIV, leading to a form of dementia. This is a patient with an oral cavity lymphoma. I can remember this patient like it was yesterday, because every day when we would go in and see the patient on rounds, that tumor would be getting bigger and bigger just right in front of your eyes due to the aggressive nature of this virally associated neoplasm. So starting off, there wasn't a whole lot that we were able to do, but there was a lot that we were able to learn. One of the first things that was noted was that there was a very clear correlation between how severe the immune system had been affected And this was reflected in the number of helper T cells in the peripheral blood. It was later shown that these helper T cells were a primary target of HIV, and as the number of helper T cells declined, the types of infections that patients may experience went from being less severe to more severe. So you see here, if you take a normal count in the peripheral blood of about 500 CD4 T cells, you rarely would see any serious infections. You might see some swollen lymph nodes. As the count dropped in the range of 200 to 500, you might see Kaposi sarcoma, thrush. This is oral hairy leukoplakia, a viral infection here on the side of the tongue, or pretty severe cases of shingles. Once the count then dropped below 200, the life-threatening opportunistic complications began to show up, including pneumocystis, pneumonia, disseminated mycobacterial infections, CMV retinitis, and here central nervous system toxoplasmosis. Prior to the identification of HIV as the cause of AIDS, all we really had to work with was the fact that we had patients with compromised immune systems dying from the complications of that compromised immune system, and really no clear therapies. There were no therapies at that time. Today, we actually are beginning to have therapies that will modulate the immune system to make it more effective. But we tried a whole array of different things, basically one after the other, most of them with very little success. Transferring lymphocytes, bone marrow transplantation, high doses of the anti-herpes drug acyclovir, what would now be called a TLR, a toll-like receptor stimulator moramyl tripeptide, interferon alpha, interferon gamma, interleukin-2, either as a crude supernatant or recombinant molecule, IL-2 also known as T cell growth factor. It made sense, since there were too few T cells, to see if we could do something by using a T cell growth factor. I knew that this was very different than anything I had experienced up to this point in my career, given the number of reporters that seemed to be everywhere where we were working. We had this reporter who wrote this story, was actually a Pulitzer Prize winning journalist for a newspaper called the Philadelphia Inquirer in the United States. He had won the Pulitzer Prize for, in fact, diagnosing and then writing about his own heart attack as it was evolving. He was very instrumental in teaching me about working with the media. And I'll never forget one time he was in the lab with us, and the Surgeon General of the United States at the time, a guy named Chick Coop, you may recall him, a tall man, big white beard, always wore the uniform, and sent this house-to-house mailer about AIDS and how to prevent getting infected. Well, in any event, Dr. Coop was in the lab, this journalist Don Drake was in the lab, and he said, Dr. Coop, why are you here, in this lab? Do you have AIDS? And he said, no, I'm just here as a Surgeon General, et cetera. When he left, the reporter turned to me, he goes, you know what, I can write a great story tomorrow. The headline would be, U.S. Surgeon General denies he has AIDS. If you look at the way the media can do things, this was clearly one example of that. And this guy, of course, never wrote such a story, although we do see similar stories today. So this was an article that I just highlight to show some of the things that we were doing at that time. This was our first pair of twins, one on the right who had AIDS, and one on the left who was his identical twin brother who was healthy. And what we were doing was we were transferring lymphocytes and bone marrow from the healthy twin Donald to his brother with AIDS, Ronald. I cannot tell you how appreciative I was of the fact that their parents tended to name the donor Donald, starting with a D, and the recipient Ronald, starting with an R. It prevented multiple confusions down the road. This was, however, the first of 30 such twin pairs. Other parents weren't quite as accommodating. This was one of those moments that you remember because it's so exciting. We had everybody came in, they would die. This patient had been immunized with something called keyhole limpet hemocyanin, or KLH, and he had no immunologic reactivity whatsoever to that KLH. After the transplant, he developed a new skin test. We really thought this would be something, but it ended up being something very transient and very little long-term improvement from that. The first thing that we saw that really gave us some hope that we would be able to make a difference were these data from a drug called interleukin-2, or T cell growth factor. we found that if we gave a 5-day infusion of IL-2 every 8 weeks, we could get, really were at that time unprecedented increases in the CD4 T cell count. Again, that's the target of HIV. As that gets lower, the risk of infection increases. And here you can see a group of patients getting IL-2, their counts going from 400 to about 1,000. And at the same time, other patients getting other treatments just had declines in their CD4 T cells. So we had this, and we thought this was, something to pursue. We did a randomized controlled trial, randomizing 59 patients to either get IL-2 plus antiretrovirals in the pink, or just antiretrovirals alone in the green. And you could see a pretty substantial and very clear difference in the CD4 T cell counts between these two groups of individuals. So having these data in hand, we were really quite anxious to see if we could do something larger and determine whether or not this was of clinical benefit. So at that time, most of the people who were working on AIDS had some knowledge of immunology, more towards infectious diseases. And I can recall having these data about the CD4 T cells going up and trying to figure out who would I go talk to about what does this mean and what might we do next. So you can see here a picture with Professor David Cooper. He was a professor even at that time, and myself from the Daily Telegraph Mirror, June 1994. And we began to work together to do studies with this drug interleukin-2. You probably can't read it here, but it's the world's most advanced AIDS research to date, where the immune system is boosted rather than the virus attacked, is being trialed extensively for the first time in Australia. So that actually began a whole series of collaborations. It taught me the value of partnership collaborations. It taught me the value of not just looking at laboratory values, but looking at the patients and the outcomes as well. So working with David and then with Sean Emery, we put together a phase 3 study of this approach involving multiple countries as shown here. We did this in conjunction with many people around the world, Jim Neaton at the University of Minnesota, Janet Derbyshire, and Abdul Babakar at the Medical Research Council in the UK, and Yves Levy and his colleagues in France, and Jens Lundgren and his colleagues around Europe from Copenhagen. We found, despite the fact that IL-2 could increase the CD4 T cell count, and here in 2 complementary studies, a SPREE, which was in patients with earlier stages of HIV infection, and SILCAD, patients with later stages, that even though IL-2 would cause increases in CD4 T cell count without causing any changes in the viral load, it did not lead to the decrease in AIDS-defining illnesses or death that we would have predicted. Based upon these increases in counts, we expected a 26% drop in AIDS or death. What we saw was 7% and 7% not being different from 0% statistically. So again, despite some promising laboratory data, the clinical benefit of this did not pan out. The real successes in treating HIV really were the downstream findings of drug discovery following the discovery of HIV as the cause of AIDS. And here you see Luc Montagnier and Francois Barry-Sunissi from the Pasteur, Bob Gallo on the right, the 2 labs that isolated and identified HIV as the cause of AIDS. With the identification of the causative agent, a whole array of research was able to take place. These data from John Mellors and the multi-center AIDS cohort study look at the relationship between the level of virus in the blood and the rate at which disease progressed and the rate at which individuals died. So again, for patients whose viral loads were under 5,000, the pink line, the rate of the incidence of AIDS-defining illnesses or death was lower. For patients with viral loads above 35,000, that rate was much higher. So again, very clear relationship between HIV, bad clinical outcomes. Bob Yarshuin, Hiroki Mitsuya, and Sam Broder at the National Cancer Institute, screening a panel of drugs provided to them by Burroughs Wellcome, identified AZT as the first nucleoside analog with activity in vitro against HIV. Margaret Fischel and her colleagues in a study sponsored by Burroughs Wellcome, a double-blind placebo-controlled trial, showed that patients randomized to receive AZT in a cohort of 282, there was 1 death. In the placebo arm, 19 deaths. In terms of opportunistic infections, 24 in the cohort randomized to AZT, about twice as many, 45, in the cohort randomized to placebo. Very clear data in the setting of a well-designed randomized controlled trial that AZT was of benefit in preventing additional AIDS or death. So that was then the beginning of the development of antiretroviral drugs. As you can see, there are multiple different drugs available today, from the non-nucleoside reverse transcriptase inhibitors, the nucleoside reverse transcriptase inhibitors, the nucleotide reverse transcriptase inhibitors, fusion inhibitors, protease inhibitors, entry inhibitors, and integrase inhibitors. Total of 13 different combination regimens available today. And really, seeing a patient with a diagnosis of AIDS today, we have a great set of drugs that we can use to really block that disease from progressing. So just as the rate of death went up from the 80s to the 90s, that rate of death and the rate of developing new opportunistic diseases dropped from the mid-90s to the year 2000. Again, a great success story for targeted antiviral drug development and drug discovery. Of course, things were not always rosy, and as was described actually by David Cooper and Andrew Carr and their colleagues here, these drugs had side effects. This is shown a patient with HIV-associated lipodystrophy with the facial wasting and the truncal obesity due to intra-abdominal fat. It became a great debate about, well, how do we balance the side effects of these drugs with the fact that they are life-saving agents? And a lot of different strategies were looked at. One had hoped, based on some modeling done by David Ho and George Shaw and others, that if you treat it for a long enough time, the rate of decline of the virus was so sharp that within a couple of years, one had hoped that maybe the virus would be gone. Unfortunately, that was not the case. And these data, taking a cohort of individuals who had been on antiretroviral therapy for an extended period of time with viral loads under 50 copies per ml, every single patient had a rebound of their virus once drugs were stopped. So in other words, even though we could really drop down viral replication, with that drop in viral replication, the CD4 T cell count would go up. In association with all of that, the patients would get better and not have new opportunistic complications. You needed to stay on the drugs because once the drugs were stopped, the viral load would come back. So that gave rise to the need to understand in a better way how to use the drug. So this particular study that, again, the team here now taking that Esprit cohort that had done the IL-2 study and merging it with some other cohorts in the US called the CPCRA, who had also been involved in IL-2, got together and ran this study called SMART, Strategic Management of Antiretroviral Therapy. And the question that was being asked here was, could we treat patients intermittently? In other words, give them the drugs for a while, then stop the drugs, give the drugs for a while, then stop the drugs. By doing that, hopefully decrease the side effects of HIV drugs and minimize the bad effects of HIV infection. So this study randomized patients to either a virologic suppression strategy where they got continuous antiretroviral therapy, or to a drug conservation therapy, a strategy where they were treated with antiretroviral drugs until their count went above 350. At that point, the drugs were stopped until the counts dropped down to 250, at which point the drugs were again restarted. The idea being that you would probably have fewer AIDS-defining illnesses in the virologic suppression arm, but fewer side effects from the drugs in the drug conservation arm. So what I can remember like it was yesterday was one of my trips to Australia when the DSMB, reviewing these data, recommended that the study stop prematurely, and the reason they recommended it stop prematurely was that everything bad seemed to be happening with an increased frequency in the drug conservation arm. In other words, some of the things that we actually thought were side effects of the drugs, such as renal disease, cardiovascular disease, hepatic disease, disease. In fact, many of these things actually were occurring with an increased frequency in the patients in the drug conservation arm. So shown here are the hazard ratios for drug conservation to virologic suppression. The farther the dot is to the right, the more it favors continuous antiretroviral therapy. As you can see, whether it was opportunistic diseases or death from any cause, serious non-AIDS events, many of which we thought previously were related to side effects of the drugs, or opportunistic diseases, everything favored being on treatment. Based upon this study, the recommendations today are very clear. If one has HIV infection and one is on therapy for that, one is better off being on continuous therapy than intermittent therapy. What that study also did was it highlighted the fact that there were a variety of things happening to the patients with HIV infection that weren't just related to immunodeficiency. This is looking at a variety of different biomarkers or measurements of, in this case, inflammation or coagulation, showing that patients with the highest levels of several of these, IL-6 being something from monocytes, D-dimer being a marker of coagulation, and soluble CD14 also being a marker of monocyte activation, that the patients with HIV infection with the higher levels of these, even though they had their viral load suppressed, were at a markedly increased risk of all-cause mortality or death. This has opened up a whole new area of research for HIV, looking at ways to try to modulate these particular biomarkers to prevent some of the long-term complications of HIV infection. So what I want to do is move a little bit, I'll tell you one other story about clinical research and how it can at times have a political influence as well, and then conclude by talking a little bit about some of the current challenges for HIV. This is a project that we did in South Africa. It was, again, a collaboration with the South African military, the U.S. Department of Defense, and with Professor Cooper and Professor Emery. This project got started because of the position of Thabo Mbeki in 2000 when he was president of South Africa, and made it quite public that he wasn't sure that HIV caused AIDS. He wasn't sure that the drugs were helpful as opposed to being toxic, and as a result, he was not going to make AIDS drugs available to the public sector of South Africa. So as a consequence of antiretrovirals not being available to the public sector of South Africa, the soldiers of the South African National Defense Force with AIDS were not getting antiretrovirals. As a consequence of that, those soldiers were dying. The soldier who was in charge, the general who was in charge of force preparedness, was a bit beside himself about what to do because he knew that there were drugs. He had been trained in Cuba. He, as many South Africans, were completely skeptical of Americans, but felt, you know, there's something we should be doing for these soldiers. So he was told that if he wanted to study the drugs, and this was from the president of the country, he could only do it through research. When he asked around, well, how do I get research started? Someone said, go talk to the Americans. He talked to the U.S. ambassador. The U.S. ambassador pulled in the NIH. When the NIH asked me to do it, I said I would do it, but only if I could hand-pick the team that goes over to work on it. And so with that hand-picked team, which included David and Sean, we launched this project known as PISA. It's a collaboration between the NIH, the US DoD, and the South African National Defense Force. It had to be done in a research venue because that's where our funding comes from Congress, and it was initiated at the request of the US ambassador. This started in late 2002 when General Hadebi discussed the possibility of collaboration with the US. We had our first meeting in 2003, worked through the governance. Again, this was trying to build a clinical research program within the South African military where no such infrastructure or activity existed. We developed a set of goals and a strategic plan, deciding to develop a state-of-the-art clinical research program within the South African Defense Force to conduct a program of scientifically valid research addressing questions of importance and relevance to South Africa with initial emphasis on HIV. This is some of the documents that led to this. It was done at quite a high level with the ambassador or the deputy chief of mission, signing agreements with the minister or with Major General. In starting a clinical research program from scratch, it really became important for us to try to analyze what is clinical research in a very precise way. So we came up with a structure that took governance up to executive committee, but parsed out all the different pieces of clinical research so we could focus expertise from outside South Africa with expertise within South Africa. We were fortunate to have Professor Emery co-chair the protocol development, and for something he's never forgiven me, Professor Cooper co-chairing the training with the Brigadier General Bless, who was actually an Austrian who had joined the African National Congress and had worked in their military. She was quite a bright person, but she was quite a challenge to work with. David, fortunately, was up to that challenge, for which I'll always be eternally grateful. This is a picture of the group. You can see it was predominantly a South African group. Just so you can find Sean Emery, he's right there with the red circle around him. I don't know where David is. He probably is somewhere working on training exercises with General Bless. He wasn't in this particular picture. This is General Hadebi with great glee with the two protocols that had been developed, largely with Sean's input. One was just an observational cohort study, the other a set of a treatment protocol to look at 4 different treatment regimens. We did this study at 3 reference hospitals and 3 rural hospitals in South Africa. The launch of the program was reported in The Economist. I have to say, in all the time that I've been working in HIV, and more recently, as Professor Phillips mentioned, in Ebola, I've never had The Economist cover what we were doing. The reason they did, though, was this was the first time that these drugs in South Africa got into the public sector. And once the soldiers with AIDS started getting better, once the number of funerals began to plummet at the sick bays, it became very clear in that country that these drugs were of value, that the president saying they were not, that they were toxic, was clearly false rhetoric. And that, I think, played a very important role in changing what was the public policy there. It was, as with many of these projects internationally, required engagement of a variety of different individuals. Here you have the African, South African Surgeon General, the African American U.S. Ambassador, and 2 traditional healers from South Africa. Just to give you an example of what the immediate impact was, this is looking at Kaplan-Meier estimates or rates of death for the patients not getting treatment compared to the patients who were receiving treatment. Unfortunately, we couldn't get people on treatment fast enough. That's why we have this group here of people who were not treated compared to the ones who were. As you can see, the higher mortalities for the individuals with the lowest CD4 counts represented by the red line in either the untreated or the treated cohorts. This program, as well as any program involving international collaborations, it's very important that there be true host country partnership or ownership, in this case with host country health agency, the U.S. Embassy, having signed agreements, a mutually agreed to strategic plan, and trying to build sustainable capacity along the way. So in the last few minutes, I just want to talk briefly about some of the current challenges for HIV AIDS research as we go into the next interval of time. Most importantly, I think, at a global level, is extending the successes we have in treatment. I didn't talk much about prevention, but prevention is very successful by using the antiretroviral drugs in individuals who are not infected or in the individuals who are. Treating the people who are infected, prevent uninfected people from getting infected, and having individuals who are negative take the drugs if they are going to be at risk will prevent them from getting infection. We have great tools now to try to prevent people with HIV from dying by getting them on antiretroviral drugs, and preventing people who are negative from getting infected by using antiretroviral drugs and a variety of other strategies. This, I think, is the most important challenge for us right now, is getting this extended everywhere that it's needed. On the research side, developing a safe and effective vaccine, and then looking to see if we can eventually cure this disease. Overall, right now, at the end of 2015, there were estimated by WHO and UNAIDS to be 36.7 million people living with HIV, 1.1 million deaths, and 2.1 million new infections. As my boss, Dr. Fauci, has written many times, here's an editorial in the Washington Post: no more excuses, we have the tools to end the AIDS pandemic. These are the targets that WHO has put forward, referred to often as the 90-90 targets. that of the people with HIV infection, making sure that 90% of them are diagnosed, of those who are diagnosed, that 90% of them get on therapy, and of those getting on therapy, that 90% of them have adequate suppression of their virus. This shows you where we are today with these goals, so there clearly is a long way still to go. In terms of prevention, we have a whole array of tools. Male circumcision, treatment as prevention. In other words, if the patient is treated, their sexual contacts are at very low risk of becoming infected. And then using antiretrovirals to prevent mother-to-child transmission for post-exposure prophylaxis and pre-exposure prophylaxis. Blood supply screening, condoms, education, clean syringes. Many, many ways we have today to try to minimize the additional spread of HIV. These are some data from a study in Rwanda showing that as the percent of individuals getting antiretroviral therapy goes up, shown here in the blue line, the number of new patients diagnosed with HIV goes down. So again, treating patients with infection will prevent others from becoming infected. Similar data have been generated in other studies, including in the US. Developing an HIV vaccine has proven to be an incredibly difficult challenge. I can remember in 1984, which is when Bob Gallo published his papers on HTLV-3 as the cause of AIDS, Margaret Heckler, who was the Secretary of Health and Human Services at the time, made a statement that within 1 to 2 years there would be an AIDS vaccine. So that was 32 years ago. The ability to figure out what element of the immune system is important to prevent HIV infection or to control HIV infection has been very elusive, and as such, it's been very difficult to develop a vaccine. The one clinical success has been this prime boost strategy with a canary pox and then a protein boost that showed about 31% efficacy. To this date, despite this study having been published in 2009, we don't have another study yet to see if these results replicate. Such studies are being initiated, but I think we've been slow in getting to this point. A variety of different strategies are being studied to try to eradicate or cure HIV infection. Latency reversing agents, histone deacetylase inhibitors, genetic modification of cells to knock out one of the receptors for HIV, enhancing HIV-specific immunity by vaccinating someone who's already infected, hoping that that will give them a better immune response than they currently have, monoclonal antibodies directed towards different parts of the virus, transferring T lymphocytes with specificity for the virus, and the use of cytokines like IL-15. And then most recently, in the last couple of weeks, a report that an antibody to one of the alternative receptors for HIV, alpha-4 beta-7, in monkeys may lead to sustained drops in viral load in monkeys off antiretroviral therapy. An enormous amount of research has been directed at studying the biologic properties of antibodies directed towards different parts of the HIV envelope, shown here in a cartoon structure. A variety of sites, this glycan shield, the place where CD4 binds, the V1, V2 apex, and the trimer where GP120 and 41 come together, and then the membrane proximal region. All of these antibodies have the ability to neutralize varying amounts or varying strains of HIV. Of note, most of these monoclonals are derived from individuals who do still have evidence of viral replication. It takes a long time for antibodies to mature to the point of having broad spectrum neutralization. Studies are underway infusing either single agents or combinations of these to see if that will do better than what we can do with the antiretrovirals alone. So I mentioned, this is just the last point, is this an antibody to alpha-4 beta-7 in monkeys with relatively recent SIV infection has been associated with prolonged decreases in viral load. This is looking at a group of monkeys on the left getting the anti-alpha-4 beta-7 antibody, on the right getting a control antibody. Both monkeys get antiretroviral therapy, shown in the gray. They get 8 infusions of antibody or IgG control, and you can see once the antiretroviral therapy is stopped, looking on the right, in the control monkeys, all of them had their SIV, simian immunodeficiency virus, viral loads go up, similar to what we saw and see in humans when we stopped their antiretrovirals. In contrast, in these monkeys, several of them had sustained decreases in their viral load out now over half a year since their drugs were stopped. Studies of this antibody are currently started in humans to see if the humans will replicate what's seen in the monkeys. More often than not, unfortunately, that's not the case. The one thing that may be a problem in terms of these eradication strategies is the fact that when HIV infects a cell, as Professor Phillips mentioned, the RNA of the virus encodes for a DNA copy. That DNA copy gets into the cell and then can encode for new viruses. Well, the HIV reverse transcriptase that encodes that DNA copy is very error-prone, such that the vast majority of the proviruses, the DNAs that are made, are defective in a variety of ways. In fact, the vast majority of the proviruses in patients are defective. They have been felt to be just archival anecdotes of what might have been. In fact, as shown here, these proviruses in patients with viral loads under 40 in the middle, these proviruses are actually capable of encoding RNAs. These RNAs are capable of encoding proteins. And what this means is that even if we suppress all the HIV, there still may be cells harboring fragments of HIV that could later on get together, recombine, and whatever strategy we have directed against the virus, if it doesn't also take care of these pieces of HIV that are persistent, may be a significant barrier to getting to the point of a cure. So in summary then, an extraordinary amount has been discovered over the past 35 years regarding the pathogenesis, treatment, and prevention of HIV/AIDS. Despite these advances, there is still much to be discovered and much to do to realize the full benefit of the prior discoveries. As we continue to move forward, it's always important to remember that we do this starting with the patients, and hopefully whatever we do ends up being something of benefit to the patients. Thank you very much for your attention.
Cliff, thank you so much for that tour de force of the subject of a very bad piece of news wrapped up in protein. We are now opening the session up to questions, and within reason, and I say that carefully, within reason we will try to answer any of your questions. You should bear in mind that the session this evening is being recorded. That's good because you can go to our website and look at it again, but it does mean that your question and its answer might also appear on the website. I just counsel you that before you say something you might regret later on YouTube. Okay, are there any questions? Yes.
Professor, you have said that AIDS is a 20th century disease. Now, there's been a few articles lately on the origins of the disease, particularly in the United States. And I remember Randy Schultz's book, and the band played on, in which he accused the very attractive French flight attendant of bringing the disease into the States. And that being the origins. And now that is being questioned, apparently, and the feeling is that AIDS was there before this guy, I forget his name, came back from Africa. What's the thinking these days about the origins of AIDS?
I think they can hear you with the...
So that's a very good question. I'm going to answer it in two ways. One, I don't think it matters to a great degree, and the sort of trying to demonize one person or another for having done something, I just think is wrong. It's obviously a serious illness. No one ever wanted to get this infection. No one wanted to take it from one place to another. I think the data in terms of looking at related viruses suggests this is something probably originating in Central Africa, from there making its way to Europe, to Haiti, to the US. But I'm not sure that it is anything other than storytelling to try to track it more deliberately than that. I think it's important to track origins geographically so we know where to look for new things, and I think because of that, as I mentioned, I think it's very important that we work hard to have robust clinical research programs in parts of the world where these new viruses may appear so that we can deal with them quickly.
But I don't think we should be in any doubt that the closest match to the current human infection is a retrovirus in chimpanzees. And in other non-human primates, they are very, very closely related viruses of this type. But retroviruses go back a long time, and in fact, Peyton Rouse got the Nobel Prize for identifying the Rouse sarcoma virus, which is actually a cancer-forming retrovirus, which he isolated in 1916. So the story of these viruses is longer than the current AIDS epidemic.
I just might add on to that. It's also interesting, if you look at the human genome, you find regions of it that appear to be old retroviruses, suggesting that what we're going through now with HIV may be part of an evolutionary process over many, many years.
So indeed, if you now sequence human genomes, which we're able to do, if you look at the data sets, it looks, depending on the estimate, that they're somewhere between 2 and 5% of the human genome is composed of retroviral-like sequences. By that is meant that the sequence has some homology to a retrovirus. It could be quite a small fragment. So it looks like these things have been with us for a very, very long time. Yes, at the back. Thank you.
Thanks for the presentation. You gave a great example of collaboration and you helped organise in South Africa. What's the collaboration or not amongst drug companies today for the greater good?
Got you.
I think it's, I don't need that, sorry. I think from my perspective, I think it's a glass half full. I think you have to look at each drug company has a motive of profit for their shareholders. I think the trick is for investigators like myself to come up with study designs that are still attractive to the pharmaceutical industry, protects their intellectual property, protects their business models, yet allows us to do more good than the drug company will do on its own. So an example of that might be that SMART study that I showed, or the one that followed it that I did not talk about called the START study, which looked at at what CD4 count would you start therapy? As soon as you make a diagnosis, or do you wait till the count goes to 350? To do that study, one needed to have drugs, and multiple different drug companies contributed drugs to do that study, without which that study could not have been done. So it's a matter of, I think, helping find that area where we can advance the field with collaboration and partnership with the pharmaceutical industry while not getting in the way of what they're trying to do. And it's a real tricky line. There are many studies that I think many investigators would like to have done that could not have been done because of some of those constraints. But I do think there are areas in which we can convince the drug companies that indeed there is reason for collaboration. I can just use one very recent example. Professor Phillips mentioned that we had been doing some work in West Africa in the context of Ebola. There we were able to compare to a placebo the GSK GlaxoSmithKline vaccine to the Merck vaccine. Both companies realized the public health urgency of the situation and were willing to work in collaboration, in this case with the NIH, to do a study.
For what it's worth, I think we have to look at this extraordinary history of 35 years, and despite billions of dollars, both the Australian form and American and pound sterling when it used to be a currency, were spent on all sorts of aspects of HIV research. But the thing that has revolutionized the outcome for patients is the drugs come out of the pharmaceutical industry. After all, Wellcome had AZT on the shelf as an anti-cancer drug. So I don't think we should demonize the pharmaceutical industry in this particular story. You could say that it is one of the great medical achievements of the 20th century, unquestionably. Any more questions?
Yeah. So up until now, the drug resistance hasn't been a big issue in HIV. And it's always been the case that developing countries kind of were not getting the new drugs as they were identified. Now that's going to stop at some stage where we won't have too many new drugs being developed. And developing countries will be using the same drugs as we're using here, for example. And we know antimicrobial resistance is a big issue in the antibiotic world because of the easy accessibility and not taking the drugs on time. Is that going to be an issue 10 years from now?
So I think antimicrobial resistance is a concern, and certainly for a virus that replicates the degree that HIV replicates, that can mutate to the degree HIV can replicate, is a concern. I can remember, though, similar discussions 10 or 15 years ago of we shouldn't be using the drugs we had in Africa because they wouldn't be used properly, people would develop resistance and they'd have nowhere to go. I'm confident that over time we will develop additional strategies. There are a variety of agents being looked at now. There are a variety of strategies being pursued. Today, in our clinic, it's very unusual to find someone with a resistance pattern so severe that you cannot come up with a treatment regimen. Part of the challenge is, as you correctly point out, is getting some of those newer drugs where they may be needed in other settings. And I think that's a responsibility for all of us. But I am not worried that we will be in a situation where we have, a super HIV that no one can treat. I think that's very unlikely.
But Clifford, in defense of the questioner's point, at earlier stages we were concerned that even though we had triple therapy or quadruple therapy, that the kinetics of the components were somewhat different, that the truck driving the drugs down the road might not arrive, that there would be transient exposure to less than the combination. And I think it was a real concern. But as we did more drug resistance testing on a larger scale, it turned out perhaps not to be the concern we had.
Yeah, exactly.
I think in terms of when the rollout program was first proposed for Africa, at least in the United Kingdom, there was some skepticism that chronic disease could be treated in Africa for reasons that weren't based on good evidence or work, but just that was the concept that chronic diseases of all sorts were difficult to treat in Africa. The rollout program has shown unequivocally that chronic disease is very treatable in Africa indeed. And this has had some extraordinary implications, not just for HIV, but for the management of such things as high blood pressure, high cholesterol in Africa and other developing countries, when it's clear that the perhaps old, maybe even patronizing colonial attitudes were wholly wrong. Yes.
You touched upon some unforeseen consequences of treating this disease, and there were others. We were involved in treating the eye infections, CMV retinitis, and many of you won't realise that that work was used to permit the treatment of macular degeneration. In 1990, if you approached someone with a needle and stuck it into their eye, it was just not done. Whereas now, if you get macular degeneration, many of you will get it because it's the commonest cause of blindness in the West. You'll be treated with an intravitreal injection. Were there other consequences of the technology aimed for treating this disease for the rest of medicine? You've touched on a few, but I'm just wondering, because we're all in our own little subspecialties, what else happened because of all this wonderful work?
So one thing that comes immediately to mind are the drugs that are now available for treating hepatitis C. I think they followed the model of what was done for targeted drug discovery for HIV, looking at similar targets like protease and polymerase, and have now come up with treatment regimens that lead to close to 100% cures for hepatitis C, which was previously one of the leading causes of death from liver disease and causes of liver cancer. The measurement of second thing is the measurement of viral loads. So again, you would see someone who might have CMV, you wouldn't look at what their viral load was. The ability to precisely measure the number of viral particles per ml of blood allows one to then direct drug therapy for HIV, and that same technology now is being extended in simplified platforms to look at a whole array of things, Ebola, malaria, tuberculosis, drug-resistant tuberculosis. Again, those technology platforms really were, I think, initially applied to the study of HIV.
I think what I would say is this, that for a long time it was thought that because viruses are so dependent on the cellular machinery for their replication and their life, it was thought that any antiviral drug would probably also have incredible toxicity because you'd probably have to interfere with some of the cellular machinery to let it replicate. That turned out to be wholly wrong, and so HIV has given us that position, but it's now clear that we should be much more ambitious in looking for antiviral drugs. It's not as difficult as perhaps we thought when Cliff won't remember this, he's so young, but when I was a medical student, viruses were thought to be somewhat untreatable. Yes?
If you look back from 81 to now, which areas do you think have been successes, great successes, and which areas have been moderate successes, and which areas have not gone particularly well and perhaps could have gone better?
In the HIV field?
In the HIV field.
So I think the big success is therapy. I think without any question, it's just amazing the difference in what this disease looks like today. I think for me, the disappointment right now is vaccines, that we do not have a vaccine on the horizon that can be used to either prevent infection or minimize the impact of infection. So I would say those two things are on the ends of the spectrum for me.
My comment would be that because of a huge amount of work done by people looking at the immune system and the virus, it was pretty apparent that the vaccine approaches that were being proposed were not going to work. Unfortunately, some of the vaccine makers didn't read my papers, and they missed the point, really. But the literature actually, I think, really substantiated the extremely difficult problem that would be to design a vaccine using the strategies we had available. If there's a real disappointment in the public health sector, I guess it's the continuing infection rates that one sees in large cities throughout the world, not only in third world countries. This is a public health problem as much as anything else, and is preventable. So that remains a disappointment. I suppose for me, one of the real successes is some of the studies that are now coming out from places like London, where the combination of treating everybody, treating people vigorously right from the outset, and pre-exposure prophylaxis plus public health education sees the sort of continuing propagation of infections suddenly go over a cliff. And I think that's what we hope for on a much larger scale in Africa. If you suppress enough of the population effectively, if you can convince people to be very, very particular about their practices, and you perhaps introduce pre-exposure prophylaxis, you can see the epidemic drop off. Where I would differ with the cure program is I think that fundamental bit of the biology where the RNA virus inserts its DNA genome into the human cells on a vast scale at the outset of the infection makes eradicating that population of cells very difficult. At the end of a long period of many years of treatment, the residual infectious load is very, very tiny, and so the analogy with some forms of leukemia outcomes plays into this. But you don't need too many cells to be left with a little bit of activity, a little bit of proviral potential to have a recrudescence. So I think that bit is also very tough.
Yeah, I would add one part to that, which gets a little bit back to the earlier question of what did the HIV experience bring to medicine in general. Prior to HIV, the immunologist had no real role in clinical medicine.
Unemployable, actually, quite unemployable.
And really, the need / desire / interest in measuring CD4 T cell counts basically made flow cytometry what it is today, an indispensable part now of the clinical laboratory. And I think that has been very helpful in a variety of fields. It's certainly been a critical part of HIV.
And I suppose it turned being a blood transfusion doctor from being a fairly sort of safe and predictable job to one that was quite problematic in the early 80s and potentially led to criminal charges against blood banking physicians for not being alive to the potentials of the virus. So that was a transition that was pretty unexpected. Fortunately, they weren't really locked up, but there was that accusation at one stage.
Mm-hmm. When part of that was actually, sadly, fueled by a competition, I think, between U.S. and French scientists about the discovery and developing a blood test, and not really, I think, looking at the bigger picture as that evolved.
But there were individual transfusion units that used the surrogate of the T4 count as potentially reflecting the presence of the infection despite the lack of a test. And so some blood transfusion services were a bit faster off the mark than that. But it was an interesting era. Yes?
What do you think will happen to the support for medical research with either of the presidential candidates?
That's for you, Cliff.
I was going to defer that one. Yeah, it's interesting in the U.S. that historically there has been more support for publicly funded biomedical research from Republicans than from Democrats. So I just make that as a general statement. We were talking about this a little bit earlier. I hope that the fundamental structures of the U.S. government will be able to handle any changes at the top. And as a consequence, some of the institutions that I do believe are very strong within the U.S. and in the U.S. government will continue to be successful regardless of who's at the top of the executive branch, which I, of course, work for, so I have to be very careful how I phrase that question. Response. Sorry?
What about international work?
I think there's a great interest, certainly from the National Institutes of Health, from my parent organization, to expand our research globally. That we think that the Ebola experience has been quite important in getting our leadership to see the fact that it is important to do research in West Africa. Zika, the same thing. It is important to do research in Latin America. Bird flu, it is important to do research in Southeast Asia. And I think the collaborations, the global collaborations, which allow one to launch a response quickly, virtually anywhere, will become important institutions to try to preserve to be able to do that. And I think there's great support for that within the U.S.
We can't be too naive about this. The stimulus to do focused research into some of these agents is often stimulated by the military. So the very serious malaria infections that occurred amongst US troops in the Vietnam War led to a tremendous program of development for drugs, new drugs for malaria, which was a very successful program. But the impetus was because soldiers were being impaired in the field. Likewise, research into yellow fever in the Central American isthmus was stimulated again by American troops going into Central America at the beginning of the 20th century and provoked interest in vaccination. So if you really want money to be thrown at some really important infectious agent, infect a few American soldiers.
And the Ebola would be another example. There were products ready to be tested in humans because that had been something that had been researched earlier on. It was felt to be an important biodefense countermeasure to have developed, so there were things ready to go.
The other industry that was always a stimulation for development of treatment for malaria was the tropical fruit programs in America. So tropical fruits in America come up from Central and South America, and yellow fever impaired the efficiency of getting bananas to America, so led to, again, another impetus. So the United Fruit Company funded a lot of yellow fever and malaria research. So another sort of commercial driver which should appeal to the Republicans. Pardon? A war. Well, it's of course down to the brilliance of an Australian. I mean, yeah. Well, that was a British problem. I mean, they didn't quite grasp that scaling it up was the thing to do, but that was partly because Floria was rather diffident in dealing with the commercial side of things. But the Americans had the means of scaling up penicillin production in the Second World War. It was the initial cultures in Oxford were done in bedpans from the hospital.
Hi, thank you very much for your presentation, and I was particularly interested in your last point there about patient perspectives, and I wondered, what are patients telling you? And also, do you have any reflections on how to balance putting out the important information, the vital information from your research, and also balancing the stigma that patients might face and, in wanting to live normal lives and have normal careers, particularly as young people?
I would say the thing that the patients bring to us from the research agenda more often than anything is this desire to not take the drugs anymore. So the pressure for a cure is extraordinary, I think, from the patient community. And I think that's reflected in the funding. So there is somewhere around $100 million of U.S. National Institutes of Health funding going to cure research right now. That was prompted by great advocacy by someone named Martin Delaney, who was an activist in the U.S., and the funding for that is done, much of that under some grants in his name. So that is the thing that comes forward most often to us in terms of an unmet research need. In terms of getting the information out there, I think it's a matter of getting it as mainstream as possible, right? When someone has a routine physical exam, HIV testing is part of it. Handing out information about HIV the way we hand out information about vaccines, making sure the public is aware. The stigma is a challenge. I think it's a matter of people accepting, people knowing people with HIV. It's interesting in the U.S., you're probably aware of this, that until HIV had the face of people the general public could relate to, like Rock Hudson, who was a movie star, like Magic Johnson, who was a basketball star, there really was a very different attitude, that it wasn't my problem, it couldn't happen to me. I think there's much less of that in the U.S. now, and again, having people speak out with HIV about how, at least the ones, who feel comfortable with that, what their life is like now, because it's so different now than it was from those pictures I showed at the beginning of the epidemic. And people not being as afraid, because if there's ways to prevent it, there's ways to treat it, that really is something that people can take that's tangible. It's something they can do for themselves, and I think putting the message in that context is very important. You had talked a little bit about the successes of early initiation of therapy. Given that now there are data that are unequivocal that start treatment once you make a diagnosis, the paradigm which used to be, well, you came in for testing, then you called for your test result, and then you were referred to somebody for treatment. That paradigm doesn't work real well. I mean, where people are moving is to the test is done while you're there in the office, and if that test is positive, you are immediately linked to your treatment program, not having gaps that the patient has to navigate. So making it easier for the patients at the time of diagnosis to immediately get into care is felt to be a very important public health aspect of doing a better job dealing with the epidemic.
And this, Cliff, relates to very much the fact that in the early phases of infection, the viral load can be spectacularly high, and therefore the infectiousness of the individual is very high. So suppressing the virus as quickly as possible should, in population terms, be beneficial over time. And we're seeing some of these cliff edge results from different cohort studies.
Yes, thank you very much for the talk. It was very informative. Is there any tissue or organ that the retrovirus attacks when it invades the body initially? Or is it systemic throughout the whole body?
I'm smiling a little bit because there are some different views on that. There is one view that says the site of replication is initially in the gastrointestinal tract. I think most of the data that one can see, particularly from the animal models, suggests that very early on, while the initial infection, will be at the site of inoculation, which will be the gastrointestinal tract, could be the oral mucosa, depending on the nature of the sexual contact. I think very rapidly there's dissemination of the virus throughout the body. Clearly the lymphoid tissue is a major target for this virus, the CD4 T cells in the lymphoid tissue. But in fact, a variety of studies looking at a variety of tissues, you can find this virus in many different tissues. So as a general statement, I would say the CD4 T cells of the immune system, the macrophages of the body, which are everywhere throughout the body, and in particular the nervous system, are major targets for the virus.
Well, one last question.
Hello again, thank you for your presentation. You've touched tonight on a lot of significant research that's happened over the last 35 years, and you've alluded to different study design and agendas and funding. I was wondering what your thoughts or comments were on, given the fact of the proportion of women worldwide who are infected with HIV, and it's not proportionate to their participation in trials, like so they're underrepresented in trials, and so how do we address that either by recruitment or participation, or what are your thoughts about, I guess, women participating in the research?
So there are, I'm trying to write the right term, so there are basically directives from the US Congress that the National Institutes of Health receive that indicate that whatever disease we're studying, we are obligated to study do our research in populations that represent where that disease is occurring. So we try very hard as we set up our clinical trials networks, as we do our studies, to do them in ways that do have gender balance, racial balance, ethnicity balance. As you point out, we're not perfect at that. We continue to try to do better. I think that certainly the studies we do with a heavy developing world emphasis tend to do better than the studies we do in the US. So it depends on the level and the type of research that's being done. We are more or less successful in achieving that balance. But it's a very important point, and it is certainly a goal.
Okay. Cliff, thank you very much indeed. So, on behalf of the University of New South Wales, the Faculty of Medicine, and the audience here tonight, I'd like to thank you very profoundly for your review of this fascinating field, your tour de force of the introduction of drugs which have proved life-saving. But also, I think we should also acknowledge your more recent work in West Africa dealing with Ebola, which again illustrates how the impact of these diseases can be extraordinary. So on behalf of the audience, I'd like to thank you very much. I'd also like to thank the staff who organised this evening's lecture. I'd thank all of you for coming, and I'd like to thank the cinematographer who's made a permanent YouTube record of this. Thank you very much.